Welcome to the Great Academy, guys. Good morning to all of you. Good morning, amazing India. So, I think most of you are here, right? So, most of you are already joined this class, right? And so today we are going to learn, or we are going to revise. Actually, we can say we are going to revise the transducer part. Okay, okay. So I hope ki, you all are doing well. Okay. Now with the new year resolution, so you have to first of all, I'm wishing you very happy new year to all of you. Right? Happy new year, guys. Are you listening me? Are you getting me, guys? Guys, are you getting me? Okay. Amazing India, Nitish Patel. Chalo. So, yeah. So today, what we are going to do is we are going to revise. Actually, this special class is only for revision purpose, right? So I hope ki you all have done with the preparation, right? And your revision mode is on, right? You all might have revised everything, right? Or you have sufficient time. Now this time, what you have to prepare for test. You have to attend as many number of tests as possible, right? And what you have to do is you have to realize your mistake what you are doing in the test series. Okay, so are you attending the test series, guys? Are you all attending the test series? How many of you have completed test series? No, means you are not attending the test series. Why? Why Amazing India? Why no? So this time, what you have to do is you have to attend the test series. You have to note every mistakes you are doing here, right? So you should not do that same mistake in the examination one, right? So what you have to do, that I'm suggesting you, just go and attend the test series. Wherever you are making mistake, you are committing mistake, just note those points in a note, and you have to work on that point only, right? So suppose if you're lacking in some conceptual based question, right? So you have to prepare for that concept only. You don't have to go beyond that. Okay, you don't have to do something new at this particular point because you have only 1 month of time, right? So and one more thing guys कि बहुत सारे लोग क्या होते हैं ना कि कहते हैं कि अरे अभी बहुत टाइम है. नो guys, so what I'm telling you is everything is easy if you are busy and nothing is easy if you are lazy, right? So you don't have to be lazy, right? You have to be active as much as possible. This is a winter season, right? So ऐसा नहीं कि ठंड है तो रजाई ओढ़कर सो गए. नो, बिल्कुल नहीं. So what we have to do is we have to revise. We have to give tests as many as possible. We have to count our mistakes, and we don't have to do the same mistake in examination hall, right? I hope you all have got this point. Whatever I have told you right now. So guys, first of all, I'll tell you who I am. So I'm Samir, and I am having 3+ years of teaching experience. I have taken so many classes of transducer. I'm also teaching analog as well as transducer control system, right? Chalo. So in this class, what we are going to do is we are going to discuss the transducer part only, right? So we will tell you where we are doing mistakes, we are committing mistakes, and what we have to do for that mistakes in this video, right? So you have to share this video. If you want to learn, you have to be till the last, till the end of this video, right? You should share this video, because देखो ज्ञान बांटने से ज्ञान बढ़ता है, right? So you will get more knowledge if you share these things, right? So ज्ञान बांटो, ज्ञान ज्यादा मिलेगा, right? चलो, so first of all, I'll little bit explain about the syllabus, right? I'll little bit explain about the mark weightage, right, and importance of this particular subject, and then we'll move to the question part, right? Okay, guys. So, चलो सबसे पहले मैं आप लोगों से पूछता हूँ, what is the weightage of this particular subject, guys? What is the weightage of this particular subject? Just tell me weightage of this particular subject. In instrumentation, what is the weightage of this particular subject? Weightage, marks. Tell me, guys. So the weightage of this particular subject is 10 to 12 marks, right? 10 to 12 marks. Weightage of this particular subject is 10 to 12 marks. Whatever I'm telling you is, guys, just listen carefully. Okay. So in this 10 to 12 marks, 6 marks is very, very easy. If you go through once this transducer, or you will get 6 marks, right? You don't have to do extra labor for this particular 6 marks, right? So 6 marks is very, very easy. Now for remaining 4 to 6 marks, remaining 4 to 6 marks, you have to study well for this particular transducer, right? For this particular 4 to 6 marks, you have to study well, you have to do proper labor, right? You have to do proper labor, you have to gain proper knowledge. And one more thing, guys, this particular transducer for instrumentation is very, very important in the interview, as well as in IT's interview, as well as in PSU's interview, right? I have attended so many interviews, and it is my own experience that if you go to some like IOCL, right, Indian Oil, then they'll ask transducer, means flow measurement, particular flow measurement they will ask, means they'll ask so many questions from flow measurement, right? They'll ask so many questions from temperature measurement, right? So not only go through the transducer, you have to gain some knowledge, some practical knowledge, right? Some practical knowledge you have to gain, and then you can attend the interview. You'll do better in this way, right? So guys, are you getting me, guys? I'm not getting any response from your side, guys. And if you go to IT's interview, right, for MTech program, if you want to, okay, amazing, India, chalo. So if you want to pursue MTech, so if you go to ITs and ITs and higher level colleges, then they'll ask you so many questions from this particular transducer. If you say, I'm from instrumentation, okay, so that's why this particular transducer is very, very important for this particular means theoretical, I can say, exam point of view, right? Now if you go for means practical point of view, so how many of you guys have attended industrial training in Indian Oil or NTPC or some big means PSUs? You might have attended one industrial training in your semesters, right? So how many of you have attended industrial training, guys? Are you listening, guys? DLW. Okay. So you have attended DLW. So have you seen any transducer there, guys? Have you seen any transducer there? Have you seen any sensor? So it's my own experience. I have attended industrial training in Indian Oil, and I have seen a lot of transducer there, right? Can't remember. Okay, no issue. But I'm telling you guys one thing. If you go for interview now in PSUs, they'll ask you this question. They'll ask you this question, where you have attended the industrial training, and if you'll tell DLW, they'll ask number of questions from this particular thing, right? So that's why you have to prepare for this particular area as well, right? So training and project both are very important for PSU's interview and IT's interview, I'm telling you, right? So whatever project you have done in your semesters, they'll ask questions from this particular area as well, right? Okay, so in IOCL, I have seen so many transducer like differential pressure transducer. I have seen level measurement transducer, right? Level measurement sensor, we can say. Slide glass I have seen there, right? In level measurement, I have seen slide glass. That shape is like inch, right? Inch scale. You have seen that inch scale is connected with the slide glass, and we can measure the level there. Okay, so I have seen so many transducer industrial training in IOCL. So this particular transducer is very, very important. You might have seen a control system design that, see, suppose, just a minute, guys. You might have seen in control system design that this is your controller, this is your plant, and this is the measurement system feedback, right? This is also the measurement system, right? So this measurement system is particularly sensor. This measurement system is particularly sensor. This is as well sensor, right? This is also a sensor. So what sensor is doing here is, see, this control feedback control system will measure any electrical quantity only, right? This feedback control system, or we can say that we can give any signal here which should be only voltage and current only, voltage or current only, right? We can give voltage or current as the input, right? But see, if we want to measure some pressure, if we want to measure some force, if we want to measure some non-electrical quantity, then also we have to form one control system there, right? We have to form one control system there. So control system is not only used to measure electrical quantity and not only used to control electrical quantity, but it is also used to control the non-electrical quantity, right? So non-electrical quantity like pressure is applied here, and this particular sensor will, what it will do, this pressure will be converted into voltage or current, especially current, right? So this pressure is converted to current. This particular transducer is called as differential pressure transducer. What I have just told you, yeah, I have seen this differential pressure transducer in Indian Oil, right? So what is the work for this particular differential pressure transducer? So this particular transducer will convert differential pressure into some electrical quantity, that is current. And this particular current, guys, tell me the magnitude of current here. What magnitude of current will get here in control system, in process control? What magnitude of current is used to operate any controller? Just tell me, guys. What is the range of current we are using to control the particular system? Anybody here? See, actually 4 to 20 milliampere current, 4 to 20 milliampere current is used in the industry to control the system, right? 4 to 20 milliampere current. So this differential pressure transducer actually converts to 4 to 20 milliampere current range, right? This differential pressure transducer actually converts differential pressure into 4 to 20 milliampere currents. Okay, guys. So this question is already asked in 2017 or 18, right? So this question is already asked in GATE examination. So if any electronic controller is there, so electronic controller will generate which range of current? It is 4 to 20 milliampere range of current, right? Pneumatic controller is used to generate which range of pressure, right? So pressure, pneumatic pressure, right? तो इस तरह से हम लोग क्या है कि हम लोग देखते हैं व्हाट इज द रेंज ऑफ द particular current or particular pressure or particular voltage. In industries, the current range should be 4 to 20 milliampere. The current range should be 4 to 20 milliampere, and the equivalent pressure range should be 3 to 15 psi, 3 to 15 psi, and equivalent voltage should be 0 to 10 volt. ये हमेशा याद रखना. You have to remember this particular range, right? This is for controller. This is for electronic controller. This is for pneumatic controller, right? So ये चीज याद रखना होगा. You have to remember. Now let's move to the question, guys, without wasting time. Okay. So see, this is our question. So this is our first question today. This is the first question, and what I'm telling you is all the questions are new and framed by me only. Okay, so you don't have to means like, array, I have seen this question, I can solve this. No, you have to attend this question. You have to solve this question step by step. Okay, in gate examination you can neglect few steps. There is no problem with that. Okay, you have to save time, you have to get marks. Okay, so smart answer you have to write in gate examination. But here before gate examination you have to do each and every step. Why? Because you can't means you can't commit any mistake here. So you have to reduce the mistake, you have to increase the accuracy as well. Okay, guys, so this is the first question. This is the first question, guys. The first question is, a 1 kilo ohm potentiometer has the power rating of 0.4 watt. See, what I have given here is the power rating of 0.4 watt is used to measure the acceleration input from a seismic accelerometer. The range of accelerometer input is 0 to 20 Z. Okay, 0 to 20 Z. And the frequency of oscillation is 20 hertz. The total length of potentiometer is 20 mm, right? The total length of potentiometer is 20 mm, right? Now, if the acceleration input is A, the corresponding open circuit voltage V naught is 8 volt. Find the value of A, right? Okay, just tell me one thing, guys. What is the G here? What is the G here? Is G हमारा क्या है? What is G here? What is the G here? What is the value of G here? Just tell me what is G. So no, nobody is giving answers, right? G is actually, guys, acceleration due to gravity, right? G is acceleration due to gravity. Acceleration due to gravity. I have expressed A, acceleration, in the terms of acceleration due to gravity, right? And the value of G, it is already given in the question. It is 10 meter per second square. G is 10 meter per second square, right? G is 10 meter per second square. It is already given in the question, you can see, right? So the question is, I'm again repeating this question. A 1 kilo ohm potentiometer has the power rating of 0.4 watt, is used to measure the acceleration input from a seismic accelerometer. The range of accelerometer input is 0 to 20 Z, and the frequency of oscillation is 20 Hertz. The total length of potentiometer is 20 mm. Okay. If the input is A, the corresponding open circuit voltage V naught equals to 8 volt. Find the value of A. Find the value of A. So here in the question they have asked the value of A for corresponding output voltage 8 volt. अगर मुझे यहाँ पे 8 volt मिल जाए, if we'll get 8 volt output here, suppose if we'll get 8 volt output here, then what is the value of acceleration, equivalent acceleration, right? What is the value of equivalent acceleration here? Okay. So what we have to do is, this is potentiometer, guys. Here power rating is given, right? So are you getting me, guys? I'm asking this question again. Are you getting me, guys? Because I'm not getting any answers from your side. I'm not getting any response, guys. Okay, that's why I'm asking, right? Okay, chalo. So this is potentiometer, right? This is our watt. So just take a screenshot of this particular question. Just take a screenshot, guys, and then I'll move to the next page, or just I'll go below, means bottom to this page. Okay, so chalo, we'll discuss first the potentiometer. So suppose this is our potentiometer and the resistance of potentiometer is Rp. What we have done is we have applied some source voltage here. What we have done is, because potentiometer is a passive element, because it is made up of resistor, right? Resistance. So this is a passive element, and you have to apply one auxiliary source here. Why? Because this is a passive element. So the passive element, suppose I have applied one auxiliary source having magnitude Vi I have applied here, right? Suppose the resistance of this potentiometer is Rp and the length of this potentiometer is Xt. Total length is Xt. Suppose the total length is Xt. Now, suppose the wiper, this is our wiper position. This is our wiper. Suppose the wiper position is like this and the wiper position is Xi in length, Xi, right? So if we want to measure the open circuit voltage here V naught, if we want to measure the open circuit voltage here V naught, what we have to do is we have to apply voltage division rule. We have to apply voltage division rule, right? So suppose the resistance of this particular part, the resistance of this particular part is R. The resistance of this particular part is R. So what we have to do is we have to apply voltage division rule. So this V naught we can write. This V naught we can write. This V naught, that is equals to Vi into R by total resistance Rp. Total resistance Rp, right? Bi into R by total resistance Rp. This is the value of open circuit voltage V naught. This is our potentiometer, right? This is our potentiometer. You can change the wiper position. You can change the wiper position Xi. I have written Xi here, right? So you can change this position, and if you change this position, you will get different voltage. You will get different voltage V naught, right? So Vi equals to R by Rp. Now, what I'm doing here is, suppose the total length Xt, the total length Xt is equivalent to Rp resistance, right? Total length Xp is equivalent to Rp resistance. So the total length Xi will be equivalent to Rp by Xt into Xi resistance, right? Right, guys? एक एक नियम पढ़ा होगा बचपन में, right? So Xt is equivalent to Rp resistance. So what is the resistance equivalent to Xi length? So Xi will equivalent to Rp by Xt into Xi length, right? Resistance. So the total resistance of this particular Xi length is Rp into Xi by Xt, right? Rp into Xi by Xt, right? So we can put here, so this is nothing but R. This is nothing but R, right? So what is the value of R by Rp? So R by Rp will be equals to Xi by Xt. R by Rp will be equals to Xi by Xt. So here we can write V naught equals to Vi into Xi by Xt, or V naught by Vi equals to Xi by Xt, right? V naught by Vi equals to Xi by Xt. Okay, have you got it, guys? Have you got it? I hope you already have covered these points, right? I hope you already have covered these points. Nobody is answering means nobody has got this point, right? Just tell me yes or no, guys. See, if you gave me answer now, if suppose I'll ask something, and if you'll give me answer, I'll get motivated, otherwise I'll get demotivated. Okay guys, so V naught by Vi, that is equals to Xi by Xt, right? Now see, we can write the value of Xi, that is equals to V naught by Vi into Xt. V naught by Vi into Xt. This is the value of Xi, right? This is the value of Xi. Now, just check the question again. Now see, the output voltage is 8 volt. The output voltage is 8 volt. Okay. So the output voltage is 8 volt. What is the equivalent acceleration we have applied here? What is the equivalent acceleration we have applied here? Just now we have seen about the potentiometer only. Just now we have seen about the potentiometer only. For this particular part we have calculated only. I have not told you about the seismic accelerometer. Now I am going to express the seismic accelerometer term, right? I am going to express the output of seismic accelerometer. Now, let I have some vibration sinusoidal signal Xi, that is equals to, or displacement Xt, that is equals to A sine omega t. Suppose I have some equivalent displacement, that is Xt, that is A sine omega t. Now we have to find the velocity. So what we have to do is, we have some displacement in sinusoidal term, right? So what we have to do is, we have to differentiate this position, this displacement. If we differentiate this position, this displacement, will get the velocity output. So velocity V, that is d by dt of xt. So this is equals to A into omega cos omega t, right? A into omega into cos omega t. Now if we want to get the acceleration, we have to differentiate it again. D square x by dt square. So this is minus A omega square cos omega t. So this is the acceleration. Right? So we can write it as omega square into minus, just take minus here, A cos omega t. Oh, sorry, this is sine omega t. This is sine omega t. So minus omega into A cos sine omega t. This is A sine omega t. A sine omega t, right? Now we can write this A sine omega t minus omega square. This A sine omega t can be written as x. So this, just take magnitude. So acceleration magnitude, that is equals to omega square into x. Acceleration equals to omega square into x, where x is the displacement, A is the acceleration, and omega is the oscillation, means frequency of oscillation, we can say. Omega is the frequency of oscillation, we can say, right? Now just check the question again. Here is the question. Now what we are going to do is, we are going to find the acceleration if the output voltage is 8 volt. We are going to find the acceleration if the output voltage is 8 volt. See, there is no relation between acceleration and output. There is no direct relation between acceleration and output, but there is a relation between output and Xi. We have already seen, right? There is a relation between Xi and V naught, right? So we have everything. We have everything here. Xt is 20 mm, which is already given in the question. V naught is 8 volt. Power is 0.4 watt, right? Hi Sinhuja, good morning. So see, now our rating is 0.4 watt and V naught equals to 8 volt. Xt, that is equals to 20 mm. So what we have to do is, we have to find Xi. So we have seen the relation Xi and V naught, that Xi, that is equals to V naught by Vi into xt. So to find xi, we don't have vi. To find xi, we don't have vi. So what we have to do? We have to find first vi. Okay, we have to find first vi. So we know the power rating of potentiometer P, that is equals to vi square by rp, right? Vi square by rp, that is the power rating. So this vi, that is equals to root under P into rp. Root under P into rp. Rp is given 1 kilo ohm or 1000, and P is given 0.4 watt. So the value of this VI, that is equals to 20 volt. The value of VI is equals to 20 volt, right? Have you got this, guys? I think you already have covered these points, right? This is just a revision class. You just have to revise this everything. Have you covered this, guys, before? Have you gone through this potentiometer before? Just tell me yes or no, guys. सब के सब गायब हो गए. कहाँ गए? अभी तक पार्टी उतरी नहीं 1 जनवरी की. बहुत पार्टी की है, राइट? Nobody is answering. Means everybody has covered this point, right? Okay. So chalo. So we have got the value of VI, that is 20 volt. We have got the value of VI, that is 20 volt. Now what we have to do is we have to find the value of XI, that is V naught by VI, that is 8 by 20, 8 by 20 into 20 mm. So this is equals to 8 mm. The displacement is 8 mm. The displacement is 8 mm. If the output voltage is 8 volt, that means the displacement would be 8 mm. We have got from this particular given data, right? So the value of xi is 8 mm. Now what we have to do is we have to find the acceleration equivalent to 8 mm, right? Now omega is frequency is already given, that is 20 hertz. Frequency is already given in the question, that is 20 hertz. So we can find the value of omega 2 pi f, that is 2 into 3.14 into 20 hertz, right? Now the value of acceleration, that is equals to 2 into 3.14 into 20 whole square into x is 8 mm, 8 into 10 to the power minus 3, right? So if you solve this problem, you will get the value of acceleration, that is 12.62 or 126.2 meter per second square. The value of acceleration equivalent to 8 mm is 126.2 meter per second square, right, guys? Now if you want to write, see, the acceleration input is 0 to 20 g. The range of acceleration input in the question is given as 0 to 20 g, right here. See, 20g, right? It is in g. G matlab what? G matlab 9.81 meter per second square. But in the question it is given as 10 meter per second square, right? G is given as 10 meter per second square. So what we have to do is we have to write in terms of G. So what we have to do is we have to divide it by 10 and multiply it by G, right? So this is equals to 12.62 G. 12.62 Z. The acceleration is 12.62 Z, right? If the output voltage is 8 volt, the equivalent acceleration should be 12.62 Z. Then only you will get the output voltage 8 volt. Is it clear, guys? Is it clear? Just tell me yes or no. Have you got this point, guys? Have you got this point? Okay, let's go to the another question, guys. There are two questions here. So the another question is, the question is given here is, if the same acceleration is measured using a voltmeter with resistance 400 ohm, then the value of V naught in volt is. Okay, so if the same acceleration is measured using a voltmeter with meter resistance 400 ohm, then the value of V naught is. अब देखो, what we have to do is we have to connect one voltmeter here. We have to connect one voltmeter here with resistance. What is the resistance of voltmeter? The resistance of voltmeter is 400 ohm, right? Now initially it was just a open circuit voltage. Now what we have to do is we have to connect one voltmeter here, and the voltmeter resistance is what is 400. Okay, now VI, what we have got, VI, the value of VI we have got is 20 volt, right? The value of RP was given as 1 kilo ohm. Okay, RP is given as 1 kilo ohm. Now we have got the output V naught equals to 8 volt, and equivalent XI we have got, that is equals to 8 mm. Okay, equivalent XI, that is equals to 8 mm. So what is the equivalent resistance equivalent to XI, guys? XI is 8 mm. So what is the equivalent resistance for this particular 8 mm length? So the total length is 20 mm. Equivalent 20 mm is equivalent to 1 kilo ohm, right? 20 mm is equivalent to 1 kilo ohm. So what is the resistance equivalent to 8 mm? So this is 1 kilo ohm by 20 mm into 8 mm. Okay, so this is 0.4 kilo. This is 0.4 kilo. So the resistance here is 0.4 kilo ohm, or it is 400 ohm. It is 400 ohm. Right, guys? So this is 400 ohm. This is 400 ohm. Now we have to calculate the output voltage V naught. Initially it was 8 volt. Now what is the value of volt? If we connected this Rm, or meter resistance 400 ohm, this Rm, that is equals to 400 ohm. If we have connected 400 ohm meter resistance parallel to this particular wiper position, then what is the value of V naught? We have to calculate the value of V naught now. Now this is again a simple problem. You have to again apply the voltage division rule only. But there is a slight difference. We have to take the parallel combination here. 400 is parallel to 400. So what is the equivalent resistance? 400 parallel to 400, that is 200. So this is 400. The resistance from here to here is 400. So what is the resistance from here to here? The total is 1000, right? So 1000 minus 400, that is 600. Okay, so 1000 minus 400, that is 600 ohm is the equivalent, the resistance of this particular part from here to here. Now the equivalent is 200. Now the equivalent is 200. So what is the value of V naught? What is the value of V naught, guys? So V naught value should be V naught equals to VI into 200 by 200 plus 600. 200 plus 600. So this is VI into 200 by 800. So this is VI by 4. VI by 4. What is the value of VI, guys? VI is 20 volt. So this V naught is 20 by 4. That is 5 volt. Right? Value of V naught is 5 volt. So what we have seen, guys, here, what we have seen here, if we connect Rm equivalent to 400 ohm, if we have connected a 400 ohm meter resistance, So the voltage drop is 3 volt. Initially, open circuit voltage was 8 volt. Now it is 5 volt. So what is the drop here? The drop here is 3 volt. This is the loading effect, guys. This is the loading effect in potentiometer, right? This is the loading effect in potentiometer. So the loading effect in potentiometer is nothing but 3 volt here, right? Initially it was 8 volt, now it is 5 volt. So there is a difference of 3 volt because of this particular RM. That's why meter resistance increases the loading effect. आप meter resistance कम add करते हो, if you add small value of meter resistance, it will add more loading effect. Okay. Okay, guys. So nobody is answering here, right? So I'll do is I'll move to the next. I'll move to the next question only. So the next question is from the gauge resistance. Okay. The next question is belongs to the gauge resistance or strain gauge, we can say, right? Now, the question is, a strain gauge is made up of negative temperature coefficient material. See, if you go through the question once completely, if you go through the question once completely, you can solve 50% of question while just going through the question. So you just have to take care in reading of the question, right? In reading of the particular question. If you read a question completely, just take few more seconds to read the question completely. If you read it completely, then you will solve. You have to think that I have solved already the 50% of the question. Okay. So reading of the question is very necessary. एंड देखो मैं ये कहना चाहता हूं कि आपको बहुत ही अच्छे से क्वेश्चन को रीड करना होगा. Okay, so you have to go through the question very carefully. What they have asked in the question, you have to go through it very carefully. See, now the question here is, a strain gauge is made up of negative temperature coefficient material having gauge factor 2.5. Okay, having gauge factor 2.5. Here the question is, gauge factor is given 2.5. And nominal resistance of the gauge is 140 ohm, right? Nominal resistance of the gauge is 140 ohm. This gauge is mounted on the metallic bar on which force of 1000 newtons is applied. Okay, this gauge is mounted on the metallic bar on which the 1000 newton force is applied. Initially, the temperature is 25 degrees C. A Wheatstone bridge is used for the signal conditioning of this particular circuit. Okay, Wheatstone bridge, as you can already see this question. Okay, so Wheatstone bridge is used for the signal conditioning circuit. Now, the gauge resistance decreases 0.1 ohm per degree C. The surface area of metallic bar is 10 centimeter square, and the modulus of elasticity of the material is 0.5 giganewton per meter square. The output voltage of the bridge for 2 degrees C change in temperature. Okay, output voltage of the bridge for 2 degrees C change in temperature is dash millivolt. Actually, what is the problem here? See, this is particularly a gauge resistance, right? A strain gauge. Okay, so a strain gauge should not have any temperature effect, but here the strain gauge resistance is decreasing with the increasing temperature, right? Strain gauge resistance is decreasing 0.1 ohm per degree C, increase in temperature. Okay, so there will be an error. There will be an error due to this increasing temperature. So for 2 degrees C change in temperature, what should be the output voltage V naught they have asked you, right? See, so what you have to do is, in this type of question, what you have to do is, you have to just go through this question once. You have to collect the data, means you have to write the data on your means whatever you will get it there, okay, on your sheet, right? And you have to analyze what they have given, what we have to do. Okay, so otherwise you will face so many problems. See, if you suppose take some part of question and started solving. You'll face so many problems. So go through the question once, collect the data, and then you have to start the answering of the question. Okay. Now, so what data here they have given? Just collecting the data for gauge resistance for a strain gauge, what they have given? They have given gauge factor ZF, that is 2.5, nominal resistance of gauge, the RG, that is 140 ohm. Okay. Now for metallic bar, what they have given, for metallic bar, they have given the value of force applied, that is equals to 1000 Newton. The modulus of elasticity, that is Y, 0.5 giga Newton per meter square. They have given area, cross-sectional area, surface area, that is equals to what they have given is 10 centimeter square, right? Yeah, this is 10 centimeter square. Now, first of all, we'll see the strain gauge concept a little bit, and then we'll see this particular metallic bar concept, right? So, depending on the given data, so what is a strain gauge, guys? Just tell me what is a strain gauge. Anybody here? What is a strain gauge? Which type of sensor it is? Which type of transducer it is? Strain gauge क्या करता है? Actually, a strain gauge is if you apply some force, on some, suppose conductor, metallic conductor, अगर आप कोई कंडक्टर पे सपोज करो ये आपका कंडक्टर है, if you apply some force here, right, so there is some, it will experience some strain. Okay, it will experience some strain. Experience strain का मतलब है, so it will either elongate, or if you apply some force like this, compressive force, then it will face some compression, right? It will face some compression if you apply some force like this. Okay, so if you apply some force on the conductor, on the metallic conductor, it will either elongate or it will be compressed, right? So we can see that the resistance R, that is hello Sohel, the resistance R, that is equals to rho into L by A. Okay, so if you increase the length of the conductor, your resistance will increases. Okay, if you decrease the length of the conductor, your resistance of the conductor will decrease, right? So this is the property, and this property is utilized, this property is used in a strain gauge. Okay, this property is used in the strain gauge only, right guys? So if you apply some force, it will experience some strain, either it is elongation or it is compression. It will experience some strain, and the resistance value will change, and the resistance value will get changed. So the strain gauge is nothing. If you apply some force, the resistance of this particular gauge is changed. And now if we incorporate this particular strain gauge in a Wheatstone bridge, then Wheatstone bridge will get unbalanced and your output voltage will get changed, right? The Wheatstone bridge will get unbalanced and the output voltage of the particular Wheatstone bridge will get changed, right? So in this way, strain gauge works. In this way, strain gauge works, right? Here I have applied the same question, I have applied the same theory here, and I'm going to discuss the answer of this particular question. I'm going to discuss the answer, the solution of this particular question. Okay. See, so metallic bar is given, strain gauge is given. We know that. Okay, just tell me guys, Those who are present here, just tell me guys one thing. So which type of bridge this is? How many gauge resistance are there? How many gauge resistance are connected here? Just tell me how many gauge resistance are connected here. Only one strain gauge is connected here, right? Only one strain gauge is connected here. So we can you already have gone through this one. You already have gone through this concept. This particular bridge is nothing but a quarter bridge, right? This particular bridge is nothing but a quarter bridge, right? So you might have studied quarter bridge, half bridge, full bridge. So this is our quarter bridge, right? This is our quarter bridge. Now, in the quarter bridge, the output V naught, we can say, we can write it as V naught equals to del, or we can write it as Vs by 4 into del R by R, right? Vs by 4 into del R by R in quarter bridge, the output voltage V naught is like this only. Vs by 4 into del R by R, right? पढ़े नहीं हो क्या तुम लोग ये सब? आप लोग ये सब नहीं पढ़े हो? Just tell me guys. पढ़े हो नहीं पढ़े हो ये सब? Okay, so this is our output voltage V naught equals to Vs by 4 into del R by R. So what is this del R? Del R is nothing but the change in resistance due to the applied strain, right? The change in resistance due to this applied strain. So we can write here, see, this V naught that is equals to Vs by 4 into del R by R, and we can write this del R by R in terms of gauge factor as well, GF into epsilon, right? So the gauge factor is defined as gauge factor equals to electrical strain by longitudinal strain. Right? Electrical strain by longitudinal strain. What is electrical strain? Electrical strain is nothing but del R by R only, change in resistance by original resistance R. And what is longitudinal strain? That is del L by L due to applied force, mechanical जिसको कह सकते हैं, right? Mechanical. So this del L by L is nothing but epsilon. इसी को हम लोग epsilon से represent करते हैं. We are representing this del L by L by epsilon. Okay. So this del R by R is written as GF, this gauge factor, that is equals to GF into epsilon. So this V naught equals to Vs by 4 into GF into epsilon. Vs by 4 into GF into epsilon. So this is Vs. Vs is excitation voltage, whatever we have applied at the bridge input, that is excitation voltage Vs. GF is the gauge factor and epsilon is the strain applied. Okay. Now, see in the question. See, क्या क्या दिया हुआ है? Gauge factor is given, that is 2.5. The gauge factor is given 2.5. The nominal resistance Rg is given 140 ohm. The force applied is given 1000 Newton. Area is given 10 centimeter square. Now, by Hooke's law, we can say that this force per unit area, that is applied stress is equals to this Y, means modulus of elasticity into applied strain or generated strain epsilon. Okay, so this epsilon is not given in the question, so we can find the epsilon as F by A into Y. Okay, epsilon is nothing but F by A into Y. Everything is given, so we can directly put here 1000 by 10 centimeter square, that is 10 into 10 power minus 4 meter square, and modulus of elasticity is given 0.5 giganewton per meter square. So this is equals to 10 to the power 0.5 into 10 power 5, 10 power 9 newton per meter square. Giga means 10 power 9. Okay. So if you solve this one, you will get epsilon, that is 2000 micrometer per meter, or this is 2 into 10 to the power minus 3. You will get epsilon, that is 2000 micrometer per meter, that is 2 into 10 power minus 3. Okay. Now by just substituting this, we can write gauge factor is given 2.5, epsilon is given 2 milli, 2 into 10 power minus 3. So this is 5 milli. This is 5 milli. Now this V naught equals to Vs is given 10 volt. You can see in the breeze. Vs is given as 10 volt here. So excitation voltage is 10 volt. So we can write volt into del R by R is nothing but 5 into 10 power minus 3 up by 4. So this is equals to 12.5 millivolt. 12.5 millivolt. So this V note is 12.5 millivolt, and this is because of a strain only and no temperature. This is because of a strain only, right? This is because of a strain only. So due to applied strain, we have got the output voltage that is equals to 12.5 millivolt because of this applied strain. Okay. Okay, guys, have you got this point? Nobody's answering, so that's why I'm feeling bored. Okay, at least you have to means answer something. Okay, guys, so this is because of a strain. We have got the output voltage 12.5 millivolt. Now what is the purpose of this temperature? What is the purpose of this temperature? So the temperature is changing. With the changing temperature, our resistance of the gauge is changing, right? So see, I'm drawing it again. This is 10 volt. You can see R1 equals to R3 equals to R4, that is 140 ohm. So this is 140 ohm. This is 140 ohm. This is 140 ohm, right? And this is our strain gauge. Here it is V naught. V naught. And this is our strain gauge. The value of a strain gauge when 25 degrees C, it is equals to RG 140. Right? Now what we have seen is the given data is that resistance of this gauge changing by 0.1 ohm per degree C, increase in temperature. The resistance is decreasing by 0.1 ohm per degree C. Now for 2 degree C change, what is the change in resistance for 2 degree C change? For 2 degree C change, the change in resistance is 0.2 ohm only, right? For 1 degree C, it is 0.1 ohm. For 2 degree C, it is 0.2 ohm. Now at 25 degrees C, the resistance was 140 ohm. Now at 27 degrees C, what is the resistance? The new resistance will be Rg new, that is equals to 140 ohm minus 0.2 ohm. So this is equals to 139.8 ohm, right? 139.8 ohm. Now if the resistance changes due to this temperature and the resistance becomes 139.8 ohm, now this breeze got unbalanced. The breeze is now unbalanced, and now because of this resistance change, our output will also change. Because the breeze is unbalanced, now the output will also change, right? Now we can write the output V naught due to this temperature change V naught. This is the due to the temperature change. V naught equals to this is 10 volt. So 10 volt into this 139.8 by 140 plus 139.8 minus what is division? Just I have applied what is division. Okay. Or we can say or you can apply Thevenin's equivalent. Okay. So V naught equals to see. Okay, just चलो मैं solve कर लेता हूँ इसको. Let's take I1 current is flowing through this and I2 current is flowing through this. So this I'm applying KVL here. I'm applying KVL. So minus V naught plus I1 into RZ minus I2 into 140 equals to 0. So this V naught equals to I1 into RZ minus I2 into 140. Now this I1 you can say I1 that is equals to this I1 equals to 10 by 140 plus 139.8. This I1 मेरा यहाँ से flow कर रहा है. I1 is flowing through this, right? I1 is flowing through this, and this I2 is equals to 10 by 140 plus 140. And I2 is flowing through this. Okay, I2 is flowing through this. Now I1, I2 I have already written. Now we can directly replace I1, I2 here. Directly we can replace I1, I2 here. So this is 140 by 140 plus 140. So this is equals to 10 volt into 139.8 by 279.8 minus 0.5. So if you solve this, you will get the value 3.57 minus 3.57 millivolt minus 3.57 millivolt. Okay. Just a minute, guys. I'm just cross checking these values. Yeah, minus 3.57 millivolt. You will get minus 3.57 millivolt. This change in output voltage is due to the change in temperature only. This change in output voltage is due to the change in temperature only. Okay, guys. But see, whether temperature is changing or not does not change the value of output voltage due to applied strain. Why? Because strain you have applied. Okay, strain you have applied, and the output is changing with the strain as well. Okay, the output is changing with the strain as well. Now, what is the total output due to strain, applied strain, plus due to the temperature? Total output, voltage, total output, that is equals to V naught due to strain. Strain is, see, a strain is not going to affect by this temperature. Okay, temperature is different thing, right? So V naught due to a strain plus V naught due to temperature. So V naught due to a strain, either you will take at 25 degrees C, or you will take at 27 degrees C, or you will take at 30 degrees C. It will remain constant. So it will 12.5 millivolt only, plus minus 3.57 millivolt. Okay, we know due to temperature. So the output at 27 degrees C is equals to 8.92 millivolt approx. 8.92 millivolt approx. This is the output voltage at 27 degrees C. Okay, this is the output voltage at 27 degrees C, that is 8.92 millivolt. You don't have to do anything else. Why? Because we have got the output voltage 8.92 millivolt. The output is decreases because of the increasing temperature. Why? Because the gauge resistance is decreasing with the increasing temperature. Okay, guys. Do you have any issue, guys? Do you have any problem till here, till this point? Do you have any problem, doubt? Amazing India, सोहेल खान, सभी कहाँ गए? हाँ, गुड मॉर्निंग. गुड मॉर्निंग कृष्णा, मैं कृष्णा से ही बुलाऊंगा आपको, आई टेल ओनली कृष्णा, ओके। Any doubt, guys? Till this point, any doubt? Okay. So I'm hoping you don't have any doubt. So I'm moving to the next question, guys. I'm moving to the next question. And the next question belongs to this capacitive filter. Sorry, capacitive transducer, right? This no next question belongs to the capacitive transducer only, right? So just tell me, guys, have you heard about capacitive transducer? Have you heard about capacitive transducer, guys? Have you heard about capacitive transducer, guys? एकदम एकदम कसम खा के आए हो कि आज कुछ नहीं बोलना है, राइट? I'll say nothing. एकदम कसम खा के आए हो, okay? Okay. So I'll tell you what is capacitive transducer. Actually, capacitive transducer, जैसा कि you can see the name capacitive transducer. Okay. So this is the transducer works on the principle of capacitance only. Works on the principle of capacitance means what? Capacitance. What is the principle of capacitance? Nothing. See, what I'm telling you is this capacitance C, that is equals to epsilon into A by D, right? Epsilon into A by D. This is capacitance C, that is epsilon into A by D. Now what is the capacitive transducer is, if your capacitor will change, then the capacitive transducer will give some output. Okay, the capacitive transducer will give some output. How this capacitance will change? If your area will change, then capacitive transducer will respond. If this difference, the distance between the both the plate is changed, then the capacitive transducer will respond. Or either if this epsilon will change, then the capacitive transducer will respond. Okay, suppose I have two plates like this. If you decrease the distance between these two plates, or if you increase the distance between these two plates, your capacitive transducer will respond. Okay, or if you increase or decrease the surface area of this particular or overlapping area of this particular capacitance, then your capacitive transducer will respond. So in this way, the capacitive transducer works. Okay, in this way, the capacitive transducer works. Same as if resistance changes, the output voltage across this Wheatstone bridge will change. If we incorporate this capacitive transducer in Wheatstone bridge only, then we will get some output voltage across the Wheatstone bridge. Okay, the same way, in the same way, the signal conditioning circuit of this particular capacitive transducer is also Wheatstone bridge only. Or we can use some operational amplifier circuit. Okay, either we can use operational amplifier circuit, or we can use that Wheatstone bridge only for signal conditioning of this particular capacitive transducer. Okay, guys. So yeah, first of all, we'll just go through the question once, and then we'll try to solve this question. Okay. So, okay, chalo. A series RLC circuit. See, I'm just reading this question very carefully, and just go through this it very carefully. I'm telling you. Ah, take some few seconds to read the question clearly. Okay, if you read the question clearly, then you have to think that I have already solved 50% of the question. Okay, in the question there are so many means small things are hidden. You have to take out those hidden things. Okay, if you just go through the question once, your accuracy will improve. I'm telling you, it is 100% right. Okay, now the question is, a series RLC circuit is shown having R equals to 10 kilo ohm. What is R here? So this is R, this is L. Okay, so this is C. RLC circuit is shown having R equals to 10 kilo ohm, L equals to 126.78 millihenry, and a variable capacitor C, The distance between fixed plate and movable plate is 20 mm. यहाँ जो आपको दिख रहा है, the distance between this, okay, the distance between this particular distance is 20 mm, right? Initially, when the movable plate is moved up by x mm, if we move this particular plate up by x mm, okay, then the current through the circuit is maximum. See, the question is the current through the circuit is maximum. Then the current through the circuit is maximum, and the frequency of oscillation is 200 kilohertz. The frequency of oscillation is 200 kilohertz. Consider the dimension of capacitive plate is 5 centimeter into 2 centimeter. The possible value of x is okay. See, this is series RLC circuit, and the current would be maximum. Current will be maximum if the circuit is at resonance only, right? If the circuit is at resonance only. So here the concept of resonance, I have framed this question on the particular concept of this resonance only. Okay, so current will be maximum if the impedance will be minimum. And at resonance in series RLC circuit, the impedance will be only R. Okay, the impedance will be only R. And the frequency of oscillation, or we can say resonance frequency, F naught, that is equals to 1 by 2 pi root under LC. 1 by 2 pi root under LC. Okay, so the resonance frequency is that is equals to 1 by 2 pi root under LC. Okay, now see. Now see, the resonance frequency, what we have seen is the resonance frequency F naught 1 by 2 pi root under LC. L is given 126.78 millihenry. C is not given. But frequency F naught is given, that is 200 kilohertz. So what we can do here is we can get the value of C here, right? So this root under LC, that is equals to 1 by 2 pi F naught. So it is equals to 1 by 2 into 3.14 into 200 into 10 power 3. Okay. Now, if we want to find the value of C, we have to square it both sides. So C, that is equals to 1 by 2 into 3.14 into 200 into 10 power 3 whole square into 1 by L. So L, if you put all the values, already all the values are already given here. Okay, L is given here. So you will get the value of C, that is nothing but the value of C, that is nothing but 5 picofarad. Okay, the value of C is nothing but 5 picofarad. If you put each values. Okay, so C is given at 5 picofarad. Means you will get some resonance at 5 picofarad. Okay, 5 picofarad. Now, see. Now, what is the question? We are going to check it again. See, the resonance will get if you increase this movable plate up by x millimeter. If you move this movable plate upward in upward direction by x millimeter. Okay, in x millimeter. Now I'm just drawing the circuit again. This is the capacitive transducer. This is movable plate. Now what we have done is we moved this movable plate by x mm up. This is our x mm, right? Now what is the distance is then d minus x. Okay, why? Because initially it was d. And the distance between these two plates is d plus x. Okay, let's take the value of capacitance generated here is C1 and this is our C2, right? So we can write this C1, that is equals to epsilon into A by d minus x, and this C2 that is equals to C2 equals to epsilon into A by D plus X. So this C1 and C2 are in series. Okay, C1 and C2 are in series. So the equivalent capacitance, C equivalent, that is C1 C2 by C1 plus C2. So this is equals to epsilon A by D minus X into epsilon A by D plus X by epsilon A by D minus X plus epsilon A by D plus X. Okay, so the value of this particular thing is epsilon A by 2D. If you solve this one, you will get epsilon A by 2D. Okay, if you solve this one, you will get epsilon A by 2D. Why? Because D square minus X square will get cancelled. Okay, now see the equivalent capacitance C equivalent, that is epsilon into A by 2D. Okay, this particular equivalent capacitance value is independent of X. This is independent of X. X से ये हमारा independent है. There is no relation between X and C equivalent. Okay, so there is no relation between X and this C equivalent. So the option 4, you can see here, the option 4, options are given. Option 4 does not depend on X will be the answer. We can't find the value of X. We can't find the value of X for this particular resonance frequency 200 kilohertz. So the answer is only does not depend on X. Why? Because the C equivalent is independent to X. Okay, guys? Is it clear? Okay. Chalo. Okay, Krishna. Chalo. So this question was related to this question has covered two topics, right? One is series RLC circuit, means resonant circuit, and the another is capacitive transducer. Okay, so see, you will get questions in GATE examination like that only. They'll not give you some straightforward question. What I have told you initially is the weightage of this particular transducer is 6 to 12 marks. Sorry, 10 to 12 marks. But out of this 10 to 12 marks, 6 marks is very easy. Suppose if 10 students will appear in the GATE examination, out of 10, suppose 7 students will know that 6 marks. They can acquire 6 marks. But for this particular 6 means 4 to 6 marks, you have to study hard. If you study hard, you will get more marks than that 7 students. Okay. So this particular 7 marks, this particular 4 to 10 marks is very 4 to 6 marks is very important for you GATE examination. Okay, guys. Chalo, we'll move to the next question now. And the next question will cover your operational amplifier part, series RC circuit part, and the piezoelectric part, piezoelectric transducer part. Okay, this is very good question. You can go through the question once, and then I'll try to solve. Then I'll start to solve this question. Just you go through the question once, then I'll read this question once, and then I'll start solving this question. Okay, just go through this question once. Let's go through the question once, guys. rescue question will come after this question, I think. So don't worry about that. Have you got any idea, guys, here? Have you got any idea here? After reading this question, see, I'm now reading this question again. A piezoelectric transducer with sensitivity of 2.5 picocoulomb per Newton, having capacitance of 1400 picofarad and the leakage resistance of 5 into 10 power 12 ohm, okay, is connected to a charge amplifier as shown below. This is your charge amplifier, right? This is the charge amplifier. A force of 1 cos 100 T, a force of 1 cos 100 T Newton is applied to the transducer. Now, the output signal is then provided to the RC circuit shown below. This is the RC circuit, and the output, this output is provided to this RC circuit only, right? Find the magnitude and phase of the output V naught. What should be the maximum value of R? What should be the maximum value of R for which magnitude will not get distorted? Magnitude will not get distorted. What should be the maximum value of R? Okay, just there are two questions in this particular question. There are two sub questions. Find the magnitude and phase of the output V naught. Here it is V naught. Here this is the V naught only. Okay, we have to find, in first question we have to find the magnitude and phase of this V naught. And in the second question, we have to find what is the value of R, what is the magnitude value of R, maximum value of R. Okay, what is the maximum value of R such that the magnitude will not get distorted. Okay, just a minute, guys. Now, first of all, I'll write every data here which is given in the question. Here, this charge sensitivity, the D that is equals to D क्या है हमारा? What is the value of D? The D is equals to 2.5 picocoulomb per Newton. The charge sensitivity is 2.5 picocoulomb per Newton. See, in the transducer chapter, okay, transducer chapter. So transducer subject, this particular unit is very important, guys. So you have to remember units. In piezoelectric transducer there are a lot of formulas. I'm telling you. So there's charge sensitivity, there's displacement sensitivity, there's some what is this? This is our voltage sensitivity. There are so many sensitivities in piezoelectric transducer. So the best way to remember this, all these things, are to remember the units of the sensitivity. Okay, voltage sensitivity, there should be some voltage. Charge sensitivity, there should be some coulomb, such as 2.5 picocoulomb per Newton. Displacement sensitivity, you will get the sensitivity in meter. Okay, so in this way you can remember all the formulas of this particular piezoelectric transducer. I'm telling you, because while I was in semesters or college, it is very difficult. It was very difficult for me to remember all these formulas in this piezoelectric transducer. But right now, I'll see the question and I'll tell you the data, whichever is given, whichever is not given. Okay, what is given here or what is not given here. Okay, so the best way is to remember the unit. Okay, if you remember the unit now, you can manage the answer. You can check the answer directly by just checking the units. Okay, and guys, please share this particular video with your friends so that they'll also get benefited for this video, from this particular video. Okay. So let me write this all these things. This D is given, the force is given, that is equals to 1 cos 100 T Newton. Okay. Now see, this is given, the figure here is given, the charge amplifier is given. This is your piezoelectric transducer. Okay, this is your piezoelectric transducer, and this piezoelectric transducer, as you know, will generate some current. It will generate some charge, and then with the help of this charge, this will generate it in some current because of this particular charge amplifier we have connected here. Okay, this will generate some current, and you know that this current I is nothing but dq by dt only. This current I is nothing but dq by dt. Okay, now this q, that is equals to the relation between q and this d is nothing but q equals to d into f. This particular piezoelectric transducer is a dynamic transducer, means if the force is changing, here the force is sinusoidal, so force is changing at each and every moment. If force is changing, you will get some output, some charge. If you apply some constant force, the output will be zero. The output will be zero. Okay, guys. So this q equals to d into f. Now this q we can write, d is given 2.5 picocoulomb per newton, and f is given 1 cos 100 t newton. So this Newton will get cancelled. So we'll get 2.5 picocoulomb only. 2.5 picocoulomb. The charge is 2.5 picocoulomb, and cos is there. So you have to write cos 100t as well. Now, what is the value of I, guys? I is nothing but dq by dt, as we have seen, dq by dt. It is nothing but dq by dt. So 2.5 into d by dt of cos 100t, right? Cos 100t. And this is I, so you will get pico ampere. Pico is there, ampere you will get. So this is equals to 2.5 minus, because the differentiation of cos is negative, okay, into 100 sine 100t. Ampere, this is the value of current here. Okay, this is the value of current. This current will flow into this particular op amp. As the op amp is ideal, no current flow into the terminals of this op amp. No current will flow into the terminals of this op amp. So the current is flowing I here will flow through this circuit only, this particular impedance only. Okay, so what is the equivalent impedance here, guys? What is the equivalent impedance here? Equivalent impedance 10 to the power 10 and 10 to the power 10 picofarad. Okay, the Z equivalent we can write, Z equivalent, that is 10 to the power 10 ohm parallel with 1 by SC, so S into 10 picofarad. So this is 10 to the power 10 into 1 by S into 10 to the power 10 into 10 power minus 12 by 10 to the power 10 into 10 power minus 12. So the value is nothing but 10 to the power 10 by, see, 10 power 10, 10 power 11, 10 power minus 12. So 10 power minus 1 plus 1. Okay, by solving this. If you take LCM, this factor will get cancelled. Okay, so you will get 10 to the power 11 by S plus 10. The impedance is like this. So what we can write is as V naught 1, that is equals to minus I into Z equivalent, right? Minus I into Z equivalent. So I we have already got minus 250 cos, sorry, this is sine 100t pico ampere. Pico means we can write 10 to the power minus 12 into 10 to the power 11 by S plus 10. So this is nothing but, here see, 10 power 1 is here, 10 power 11 is here, so it will get cancelled. So it is 25 sine 100t into 1 by s plus 10. So here it is, guys. This is V naught 1. This is V naught 1, right? Now you might have studied steady state response in frequency response analysis control system, right? Steady state response in frequency response analysis. Okay. If this is the input, this is the transfer function. So we can write it as the input frequency is what? 100 radian per second. Input frequency is what? 100 radian per second. So we can write it as 25 by root under omega square plus 10 square into sine 100t minus tan inverse omega by 10. You can put the value of omega, that is 100, because input frequency is 100. In steady state sinusoidal response, the input as well as output frequency will never change. Will be both will be same only. Only the magnitude and phase will be changed. Okay, magnitude and phase will be changed. So the value of this particular thing is 0.2478 sine. If you solve this by putting omega equals to 100 sine 100t minus 84 point some degrees. Okay, 84 degree. Let's take 84 degree. Okay, it is approximately 84 degrees after putting omega equals to 100. Now this is the V naught 1. This is the V naught 1, guys. This is the now this B note 1. Now the another part is this B note 1 will be given to this RC circuit, this RC series circuit. We note 1. This R equals to, it is given as 2 kilo, and this is given as 10. Let me check this one. This C is given as 10 microfarad. Okay, C in this another circuit, second circuit here. C is given as 10 microfarad. This is 10 microfarad. So here we can see that this particular circuit is, okay, just tell me guys one thing. This particular circuit is which type of filter? Which type of filter it is? So there was some technical error, means internet issue. Okay, now the value of omega. Now are you getting, guys? Are you getting, Krishna? Now the value of omega is nothing but omega equals to 1 by 2 into 10 power 3, that is r equals to 2 kilo ohm, and the value of c, the value of c is given as 10 microfarad, so 10 into 10 power minus 6, right? So you will get the value that is equals to 50, that is equals to 50. Okay, so omega equals to 50 radian per second. Now see, if you apply v naught 1, that is equals to this one, V naught 1, that is equals to this one, 0.2478 sine 100t minus 84 from something degree. So the value, the frequency of this particular V naught 1 here is 100 radian per second. This is 100 radian per second. But the cutoff frequency of this particular filter is 50 radian per second. So just tell me, guys, this is LPF, low pass filter. Will this filter allow this particular V naught 1? Will this filter allow this particular V naught 1 signal? Will this filter will allow? Will this filter allow this particular signal? Because this is low pass filter, the cutoff frequency is 50 radian per second. So this filter will not allow 100 radian per second component from this particular filter. Okay, so you will get output. You will get output in this case that is equals to 0. Why? Because the cutoff frequency is lower than whatever we have applied at the input frequency. Okay, so output will be 0. Output will be 0. Now, another question is, guys, another question in this particular question is, what should be the maximum value of R for which magnitude will not get distorted? What should be the maximum value of R for which magnitude will not get distorted? This is low pass filter. This is low pass filter, and the cutoff frequency of this particular low pass filter is 50 radian per second. But the input signal having the frequency component is 100 radian per second. So what we have to do is we have to increase the value of this cutoff frequency. Okay, we have to increase the value of this 50 radian per second frequency. Then only this filter will allow that particular magnitude, that particular voltage signal. Okay, so the value of omega, that is 1 by RC, that should be cutoff frequency should be greater than the frequency applied at the input. The frequency applied at the input. Okay, the cutoff frequency should be greater than the frequency applied at the input. So the value of R should be less than 1 by 100 into C, or the value of R should be less than 1 by 100. C is fixed, that is 10 microfarad. Okay, so the value is 1 kilo ohm. Okay, so the maximum value should be 1 kilo ohm. If you keep it 1 kilo ohm, the cutoff frequency will become 100 radian per second. Okay, if you keep R that is equals to 1 kilo ohm, the cutoff frequency will become 100 radian per second. Okay, guys, are you getting me, guys? Are you getting me? Guys, are you getting me? Just tell me, are you getting me or not? So the value of R should be less than 1 kilo ohm. Then only we'll get the cutoff frequency, that is 100 radian per second. Okay guys. Chalo. We'll move to the next question now. We'll move to the next question, guys. This question belongs to an LVDT. Now, guys, just tell me the full form of this LVDT, because so many of so many of students is having wrong knowledge about this LVDT full form. See, they are telling linear variable differential transducer. They are telling, what they are telling is linear variable differential transducer. Okay, but the full form is linear variable differential transformer. Okay, linear variable differential transformer is the right form of this LVDT, right form of this LVDT, right name of this LVDT. Now the question is on your screen. The question is on your screen, guys. Question is, I'm just reading this question. An LVDT as shown below had sensitivity of 40 volt per millimeter. An LVDT as shown below had sensitivity of 40 volt per millimeter. And a sinusoidal displacement dt, that is equals to 0.1 sine omega t millimeter, is provided at the core of LVDT. See, the question is, an LVDT as shown below had sensitivity of 40 volt per millimeter, and a sinusoidal displacement dt, that is equals to 0.1 sine omega t millimeter, is provided at the core of LVDT. Okay. Signal E differential, that is equals to, I'm just writing this data. dt is given as 0.1 sine omega t millimeter. E differential is given as E differential, that is A sine omega 1t. The supply voltage at the primary side is 5 sine 2000 t. EIT is given as 5000, sorry, 5 sine 2000 t volts. Then possible value of A and omega 1 such that there is no distortion are respectively. Then we have to find the value of A and omega 1 such that there is no distortion at the output. Okay, there is no distortion at the output. Okay guys. Now see guys, now this is 5 sine 2000. Now see, what I'm telling you is, there is no distortion, there would be no distortion. Suppose there would be no distortion if and only if the excitation frequency, okay, the excitation frequency and the displacement frequency, okay. So suppose this excitation frequency is Fe and the displacement frequency is Fd, okay. The ratio of this Fe by Fd would be less than equals to 10. Okay, that would be less than equals to 10. Okay, okay, sorry, this should be Fe by Fd, that should be greater than equals to 10. Then only there is no distortion at the output. Then there is no distortion at the output. Okay, let me just write the, this is our displacement. Okay, so displacement frequency we can see here is omega. The displacement frequency Ft, that is omega. Okay, and the excitation frequency EIT, that is equals to 2000. That is equals to 2000. So Fe, that is equals to 2000. This is radian. We can write it as radian per second. This is also radian per second. So the value of FD, we can write from here that FD should be less than equals to FE by 10. Okay, FD should be less than equals to FE by 10. So this FD should be less than equals to FE is 2000 radian per second. This is by 10. So this is equals to 200 radian per second. The value of FD should be less than equals to 200 radian per second. Okay, the value of FD should be less than equals to 200 radian per second. Now the LVDT at the output side, you will get two components. Okay, you will get two components of the frequency, FE plus minus FD. Either FE plus FD or FE minus FD. You will get two components here. So FE plus FD is nothing but 2000 plus 200, right? Or 2000 minus 200. So this is equals to 2200 radian per second or 1800 radian per second. 1800 radian per second. So there are two frequency components here. Okay, 2200 radian per second and 1800 radian per second. Okay, so we can see in the answer. Okay, let me tell you one more thing. The sensitivity of the LVDT is sensitivity of the LVDT, that is equals to 40 volt per millimeter. Okay, 40 volt per millimeter. But you can see dt is given as 0.1 sine omega t millimeter. So what is the magnitude here? Magnitude is 0.1 millimeter. Then what is the output magnitude? That is 40 volt per millimeter into 0.1 millimeter. So this is equals to 4 volt. Output would the magnitude of output would be 4 volt. Okay, the magnitude of output would be 4 volt. Now the answer will be, see the answer. See, there are four options: 4 volt and 2200 radian per second, 4 millivolt and 2200 radian per second, 4 volt and 1800 radian per second, 4 millivolt and 1800 per second. Okay, so we can directly see that this question is from MSQ. Okay, so this is MSQ. There are two answers which are right. Okay, the first option and the C option, third option. Okay, both are right. 4 volt and 2200 radian per second, 4 volt and 1800 radian per second, both are right. Okay, both are right. So we have to check each and every steps very clearly. Either two options are right, either three options are right, either all options are right, or only one option is right, because there is a slight change in the examination pattern. Okay, so you have to go through all the options. Initially what it was like, if you get one answer, you can click on one answer only. Now because there are more than two answers correct, you have to check each and every options, then only you can click the options, you can click the right options. Okay, so see, so many things are important for GATE examination. You have to go through the questions very carefully, you have to check each and every data very carefully, and you have to go through all the options very carefully. There may be more than one answer correct. Okay, so you have to check it very carefully. You have to see the units very carefully, whether microvolt or millivolt, what is written in the question. Okay, then you can put your answer in the net type question, or then you can check, then you can select the option for MSQ or MCQ questions. Okay. So students, this is the time to wind up our this session. For next session, already you might have got the timing. Okay, so be available on this particular time. We'll discuss the next means non-electrical parts of the particular transducer. Okay, like pressure measurement, level measurement, uh, flow measurement. We'll discuss some more questions from this particular parts. Okay, so be available for this particular question for this particular session. Okay, and please be like and share these videos with your friends so that they will also get benefited. Okay, chalo. We'll wind up. We are going to wind up this particular session. So all the best, guys. तैयारी करते रहो। चलो बाय।